Okay, in this Flip Learning task to support the Developing Fuels chapter, we're going to be learning how to classify hydrocarbons and use different terms to describe different types of hydrocarbons, in particular aliphatic and aromatic hydrocarbons. So a couple of terms first from your GCSE. You'll remember the term unsaturated, and this means that a molecule contains carbon double bonds. Saturated molecules contain no carbon double bonds. So looking at the three molecules here, alkenes here are unsaturated and alkanes are saturated. Similarly, cycloalkanes are saturated. Over on the right hand side here we've got this molecule which is called benzene, and in benzene there are carbon double bond carbons, and so this is again an unsaturated molecule. Okay, so from your GCSE days you'll remember the term hydrocarbons to mean any molecule that contains hydrogen and carbon, and this covers a great number of the molecules that you'd find in crude oil. There's two main groups of hydrocarbons that you need to be aware of, and we're going to use the terms aliphatic and aromatic to describe these. Let's start on the right hand side here with aromatic molecules. Now, very important for you to recognise this structure here. This molecule is known as benzene. You'll also see this written in a different way, like this, with a circle inside a hexagon. Now, this structure represents the fact that the electrons from these three double bonds in the benzene ring are what we call delocalized. It's delocalized, a word you'll have heard before, applied to electrons in metals and possibly in graphite. And delocalized means that those electrons aren't tied down to a location in between just two carbons, but they can actually move all the way around the ring, and those electrons are spread across the 6 carbon atoms. You'll learn much more about this later. But for the moment, as long as you can recognise benzene drawn in this form or in this form with 3 double bonds, or possibly in the skeletal form like this with a hexagon with the 3 double bonds shown. Anywhere where you see a benzene ring in a molecule with these delocalized electrons, that's going to be termed an aromatic hydrocarbon. Aromatic hydrocarbon. So even if it's a much bigger molecule that it has a benzene ring in, we'd refer to that hydrocarbon as an aromatic hydrocarbon. Okay, let's move on to the left hand side of the diagram, and I've put 3 subgroups of hydrocarbons here, all under the heading aliphatic. And probably the simplest way for you to think about this is that if a molecule isn't aromatic, in other words, if it doesn't have any benzene rings in it, that molecule can be termed aliphatic. So looking at these 3 groups down the bottom, we've got the group of alkanes. You'll remember these from GCSE again. These are molecules with the general formula CnH2n plus 2. So for instance, C2H6, this is ethane. No benzene rings, so these are aliphatic. But a couple of groups that you might be less aware of, or certainly the cycloalkanes you might have seen before. This is a molecule where you've got an alkane chain joined together into a ring structure, into a cyclic structure. And again, no benzene rings. Even though it's got a cyclic structure, It's got no delocalized electrons in there, and no benzene rings, so this is also an aliphatic structure. Alkenes you will have heard of in your GCSE, and you'll recognise the carbon-carbon double bond. So this is an aliphatic hydrocarbon because there are no benzene rings. Okay, let's try a couple of examples and see if you can decide whether they're aliphatic or aromatic, and also can you decide what type of hydrocarbon they are. Okay, we're drawing skeletal structures here, and have a look at this molecule and stop the video, decide which group of hydrocarbons it belongs to. Okay, straight away you can see that this has got a benzene ring, so it must be an aromatic hydrocarbon. What about this one? Stop the video, decide aliphatic or aromatic, and then start the video again and we'll discuss it. Okay, so this molecule, it has a cyclic structure, and in fact it has a double bond, but the key point here is it has no benzene rings. Remember, for a benzene ring it has to have the 3 double bonds delocalized across the benzene ring, either drawn like that or drawn like this. So this is an aliphatic hydrocarbon, and in fact it's an alkene because it's got this carbon-carbon double bond. Let's go to another molecule. Okay, have a look at this molecule, decide what type of hydrocarbon it is, stop the video, and then restart and we'll discuss it. Okay, once again, look at it carefully. You'll see that there's absolutely no benzene rings, so nothing that looks like this, nothing that looks like this. So there's no benzene rings, therefore it must be aliphatic. And you should immediately also see that it's got 1, 2, 3 double bonds, and that means it's an alkene. Okay, what do you think of this molecule? Aliphatic or aromatic? Well, straight away you can see that's a little bit complicated, but you have definitely got this benzene ring structure here with 3 double bonds in a 6-membered ring, and that's a benzene ring, and in fact this is a molecule with 2 benzene rings fused together, sharing this side here. So this is aromatic. Okay, so far in this flip learning video I hope you've learnt the term aliphatic and aromatic, saturated and unsaturated, and let's just quickly talk about the terms functional group, homologous series and arene. Now, starting with arene, arene is actually a term that you'll see used for aromatic hydrocarbon, so just the same idea as aromatic. Sometimes it'll be called aromatic, sometimes you'll see the molecule described as an arene. So benzene is an arene. Okay, the term homologous series. Now, you're familiar with the series of alkanes, so this is a series of molecules which starts with methane and increases in size by a carbon and 2 hydrogens for every member in the series. So CH4 and then C2H6, you've added an extra CH2 group. The third member in the series is propane, which has added another CH2 group, butane, another CH2 group, and so on. So the relationship between the molecules in the homologous series of alkanes is their series of molecules with the same general formula. So the general formula is CnH2n plus 2, and they differ from each other by a CH2 unit each time. Homologous series, same general formula, but are different by CH2 every time. Okay, what about this term functional group? Now, you'll be using this term a lot over the next couple of years, but let's just introduce it very simply at the moment. If you had a slightly more complicated molecule such as this alcohol, and this alcohol has the name propan-1-ol, more of that later, but you can see that it consists of a hydrocarbon backbone of 3 carbons joined together, so a CH3, a CH2 and a CH3. Remember your skeletal formulae from the previous video. And then attached on this end we have this OH group. You'll learn to call this a hydroxy group or a hydroxyl group or possibly an alcohol group. And this is the part of the molecule that's often involved in chemical reactions, so we call this the functional group. Let's quickly give you a couple of other examples. So we've been talking about alkenes. There's a simple alkene. The double bond part of the alkene is the functional group. It's the part of the molecule which is different from the hydrocarbon backbone. And you'll meet lots of other examples over the next year or two.